When 3D printing, you usually only care about a few slicer settings and not about every motion the printer makes to produce the part. But what if for some reason you do care about the exact toolpaths? Generally, an STL is imported into a slicer, which converts the geometry into layers and generates toolpaths and G-code based on the settings. This workflow usually works and requires minimal user effort. However, because slicers are built to handle basically any geometry rather than being optimized for specific ones, their inherently general approach, despite offering many tunable settings, can become a limitation in certain cases. I came across such a case when I wanted to 3D print a thick bead seamless container. I tried to achieve this by using various slicer settings, but I couldn't get the desired result. This led me to write a script that generates the G-code, as writing it manually would be too tedious and a waste of time. I made a first version in Python which generates the G-code for the container based on the user-defined parameters like diameter and height. After printing a few iterations and refining the code, I achieved a satisfactory result. I realized that this tool could be useful to others or inspire them to create a similar tool using a similar approach, so I decided to turn it into a web application and make a video about it. On the left, you enter the parameters, and on the right, the visualization shows you the toolpaths, beneath which you can paste your own start and end G-code after comparing it to mine if you're using a different printer. Running the code is at your own risk, so I recommend babysitting the first print to ensure everything works as expected. As you can see, the container is printed as a continuous spiral with a constant flow rate, resulting in a clean, seamless finish. The transition from the first layer to the wall is done gradually, resulting in it being barely noticeable. I've also been experimenting with variations I want to incorporate in the future, like a wavy circumference or a taper in the vertical direction. If you have any more ideas you would like to see become a reality, you can let me know in the comments. You can find a link to the web application and the GitHub repository in the description. I hope some of you will find this useful and maybe even make a pull request with improvements or new features. That was it for this video. If you have any questions, you can ask them in the comments below. Please consider subscribing and I will see you in the next video. Thanks for watching. Bye.